Hello everyone, and welcome to today's section, which is our architectural design patterns in Android. So this is kind of a first look now at we're going to kind of restructure and refactor our donation app and bring in some of these kind of new design patterns. The one we're going to look at is MVVM, which I'll cover in more detail later on. But in this section, I just wanted talk about kind of design patterns in general, and specifically then the architectural design patterns, which is kind of a more recent addition. Okay, so the way I've broken it down is as follows. Start off with a quick introduction. So again, just trying to put things in context for you about why design patterns are so useful and so important within the development world. We'll look at an overview and some benefits of using design patterns. We'll then take a high level-ish view look at MVC, MVP and MVVM. Okay, so model view controller, model view presenter, and then model view model, and then just a conclusion just to kind of wrap up the section. Okay, so just to begin with, just to kind of, as I said, put things in context. Okay, so mobile development has changed greatly in terms of not only what is capable on a device, but also in terms of what users want and expect out of the average app. So look, it's only been around since 2007. That's when the first Android app was released. Okay, our Android device, and obviously apps come with that. But if you look at what your phone can do now, and what the new additions over the last couple of years, especially, I guess, they've changed a huge amount. Okay, so what's capable on a device has massively changed, right? So with that, developers have had to change how they build things in order to account for more complex, robust apps, and it's all tied to scalability. Okay, so like as the apps and the frameworks bring in more features, it gets more complex, it just gets harder to manage. Okay, so again, that's what we're trying to kind of highlight here, that you can't just dive straight in and just start coding if it's going to be quite a complex app, right? And again, just if you want it to be robust, if you want it to be scalable, you want it to kind of stand the test of time, there's a bit of thought has to go into it. Okay, so the Android development community in particular has had a huge shift in focus from massive logic heavy activities to MV whatever based approaches to help split up the logic. So again, especially working in teams, right, it's all about kind of trying to split up into smaller components and less coupled, so decoupling those components, moving away from those logic heavy activities. Okay, and again, we'll kind of refer to that now when we look at the different patterns. Okay, a little bit more on the introduction there. So with the adoption of Kotlin and the introduction of architecture components, so again, we're going to look at those in the next section, but these are kind of a recent addition to the Android framework to just help improve design, basically, okay, within an Android app. So it's now much easier to get off the right foot with new Android apps to help ensure their maintainability and scalability for the future. Excuse me. However, as those apps have had time to grow and mature in the wild, it is often necessary to employ other design patterns to allow apps to grow without becoming unmaintainable. So again, I think I'll talk about it later on, but initially MVC was kind of the chosen approach, but that was okay when the features that you could implement in an app were pretty straightforward. They weren't too complex. But as you see yourself with the devices and your kind of retina scanners and all the kind of sensors and locations, and there's so much more you can do with an app now to try and manage all that with MVC has kind of gotten a bit out of hand. So that's why as time went by, developers had to try and apply other types of design patterns, and we will discuss three of the most common Android architectural patterns: MVC, MVP, MVVM. Their main purpose of producing scalable, maintainable and testable code, and that's a big one recently as well. Just being able to test your code. Initially there was very little testing done, but as apps got more complex, testing became more and more important, because you can't leave an app out there and then within a couple of weeks there's bugging, there's bugs in it, there's crashing. So to make things easier to test, it can be driven by the type of design pattern that you want to apply as well. Okay. So to look at some of the benefits, again, kind of an overview as well, okay? So what are design patterns and why are they useful? So design patterns represent reusable architectural building blocks within a program. Good building blocks in your code will lead to clean code, resolve common problems using common paradigms, making it easier for multiple developers to work on the same project, be robust and well tested, and be easier to understand and maintain. So with design patterns, developers can apply known solutions to existing problems. So again, design patterns, they've been around a while, and they're a kind of a tried and tested way to build Android applications, okay, and any application for that matter, right? It just happens that obviously we're talking about mobile at the moment, Android, but design patterns can be applied in any context, okay. The concept of design patterns appeared in a famous book by the same name, so the Gang of Four, right, which described 3 categories for these patterns. So again, it kind of even goes back to engineering, and that's kind of where it came from originally. And then it ended up, again, I'll talk about it a little bit later on, ended up kind of coming into the web world, and is now leaked into every other facet of development and types of different development applications that can be built, okay. So there's kind of 3 main categories that initially were there, right? You had your creational, so it delivers solutions for creating classes, objects. Some of those mentioned there would be, you might be familiar with, the singleton factory builder patterns. We have a structural category, which are about arrangement of classes and objects, so your composite facade adapter. And then behavior gives you ways to communicate between those objects and classes. So again, specific ones there would be command, observer, and strategy. Okay, to look at it just in a kind of a more complete list of the 3 different categories. You may be familiar with some of them, you may not. If you want, you can go off and kind of investigate those in more detail. I'm not going to do that today. Okay, just going to focus on the ones that are applicable to us. Okay, but more recently, there's been a 4th category has come on the scene, right? These architectural design patterns, which helps developers follow an architectural style. They help you separate different components within a project. So again, as our apps get more and more complex, there's more and more cogs in the wheel, so to speak. There's more and more components that are coming together to work together to build that particular app, okay? So in the enterprise world, one of the most popular design patterns is the 3-tier or 3 layers pattern, right? Another useful one is the client-server model. And then mobile apps also benefit from many of these patterns, but some work better than others. So that's what we're going to look at now. We're going to look at 3 of the most common architectural design patterns that work for mobile apps, and kind of little compare and contrast, and try and impose upon you why, at the moment anyway, MVVM would be the better approach. Okay, so to look at, as I say, common architectural design patterns within Android. But look, a lot of these are applicable in the web world, desktop, most basically development type applications. Okay, so the model view controller, or MVC, and your model view presenter, MVP, are 2 design patterns that are very similar and have much in common with MVVM, but there are subtle differences, and that's why we're going to be using and applying the MVVM pattern. Okay, now, just as an FYI, I think I mentioned this already, Google didn't push for one single design pattern for Android in the beginning. However, the documentation used MVC more often than not. And as I say, at the time, because Android was only kind of in its infancy, the features and the library itself wasn't that rich in terms of what you could do with the mobile app. So the MVC approach was perfectly fine at that particular time. Okay, but as we'll see, when compared to the other patterns, and when Android apps started getting more complex, MVC wasn't really the best approach. Okay, so now this pattern has 3 components. Again, the model view controller, hopefully you're familiar with some of this, but we'll just briefly describe it again. Oh, sorry. So an MVC, communication between components, looks like a triangle. And again, I'll show you now a little diagram next. in general terms, the view displays the state of the model, the controller handles the view input, and the model stores the result that comes out of the controller. So in the Android world, the model, if we work kind of ground up, would have been your the data would have represented the data you're trying to show, which then would have been displayed in the view. The controller manages that, handles that view input, and in the Android world, the controller would have been your activities, which unfortunately leaked into the view as well with your layouts. Okay, so as I say, initially that was fine, but as things got more complicated, that merging of components really wasn't made it difficult to scale, and as previously mentioned, you ended up with these very logic heavy activities which is hard to manage essentially. Okay, so to look at it in a diagram perspective, just a nice graphic, we have our, just highlighted for you there, so here's our model, our view, and our controller, and the user interacts with the view. The model will send updates to the view, and the view then sends events to the controller. So that's like, say the user might be looking at a view, a screen, a layout. They click on a button, that's an event. It's sent to the controller. Maybe it could be you want to list some data, so the controller then manipulates the model, goes off and gets your list of data, and then sends it back to the view. Very straightforward, easy to understand, easy to get your head around, and easy enough to implement as well once your app wasn't that complicated. Okay, it's just a problem started arising when apps started getting a little bit more complex. Okay, now a little bit more about MVC. It can be hard to test because of this communication model. Navigating the code can also be tedious, so the business logic should be split between the controller and the model, but sometimes the logic leaks into the view. Okay, this creates a kind of coupling that has a spiral effect. So in the end, it encourages Android developers to put the bulk of the code in an activity or a fragment, again, which gets totally out of hand, right? And this makes the app hard to maintain and nearly impossible to test. So it ended up, the MVC ended up getting called the massive view controller as a kind of a nickname, because obviously same initials, but it just got very, very out of hand, and your activities were getting far too big. Okay, despite this, the pattern is still good enough, as I say, for small projects, but there are better patterns available, and that's what we're going to look at. Okay, you may not have heard of MVP, but again, we'll discuss it here in a little bit of detail. So the MVP, or model view presenter, shifts the controller in MVC between the model and the view, naming it presenter. So there's a slight little bit of decoupling there. Okay, it helps concentrate the business logic in the presenter. So the less logic that you have in your view, or from an Android perspective, in the activity, the better. Okay. On the flip side, the presenter is also responsible for adapting the data in the model for displaying in the view. Okay, sometimes then it's kind of called a supervising controller, because it's a kind of managing and adapting that data. Okay, so the difference between MVC and MVP, it's not huge, but decoupling the model from the view has advantages. And now this is all leading up towards the MVVM, and this is where those architectural components, our view model, our live data were kind of born out of. Okay, so it's useful and it's good to understand the kind of the principles behind these design patterns initially, because it all kind of built up towards this the MVVM. Okay, final point there, it allows for more flexibility and offers easier UI and unit testing. Okay, so to look at the our MVC, so there's our MVC again, right? But if we compare it to our MVP, you can see it there. So there's a total shift there now. You can see it. The model is not dealing with the view at all. Okay, so here's our model and the view, and that's always a good thing, because if something as simple as the user rotating the screen, if that is dealing directly with the model, you could have memory leaks, you could lose data. So these are all, there's some of the common issues tied to that original MVC. Okay, but you can see here now, if the model dealing exclusively with the presenter, or as we call it sometimes, that supervising controller. So as before, views, if we have the view, your layout could be a screen with a few buttons on it. User clicks on the view, event, that's an event sent to the presenter. As before, manipulates the model, but this time the model goes back to and reads from the presenter, okay? And the presenter will send then any updates back to the view. So this decoupling of the model and the view is it's subtle, but it's very important, okay? Now, to talk a little bit about MVVM, which is the model view view model, okay? So this is currently one of the most loved patterns out there, as it has had plenty of time to mature. Again, it's been around a long time, adopted by the web community there and within Microsoft there, formalized it back in 2005, and it has eventually made its way into every UI-based framework. So again, the fact that the UI-based framework is very, very important, because it's all about that decoupling of your data and working with data and retrieving data, updating data, and separating that and decoupling that from how it's presented. Okay, so one of the key advantages of MVVM is that it offers the right amount of decoupling. Another is that the learning curve is similar to the other patterns. So if you have a good understanding of MVC or MVP, getting your head around MVVM isn't that big a jump. Okay. Just to talk about it in a bit more detail now, has three components: the model view and the view model. And again, this will map directly to those architecture components that Google now have in the SDK, right? The MVVM itself includes a fourth component, right? Even though it's not mentioned in the title itself, fourth component, which is a binder. And again, we look at that now in the next slide. And again, within the Android world, applying our MVVM approach will also involve some kind of data binding, and there's data binding libraries there for us within Android to make that happen also. And again, we look at that later on. Okay, so if we look at the MVVM, quite different to the original, but not hugely different. So again, here we have our model. The key here, again, look, model, no direct contact or talking interaction with the view at all. So again, view deals with the user, will be kind of, again, we use the same example, clicking on a button on a list, sends events to the binder, and it's the binder then will pass on that to the view model, which in turn will send it back to the binder, which it then passes back to the view. And the view model deals deals exclusively with this view model. So our model is kind of like our raw data. Okay, so from the Android perspective, the model could be a flat file, could be a database, local database connection, could be a cloud connection, could be an API, but that is all done and manipulated through the view model. Okay, so again, there's a quite nice decoupling. There's a nice balance of decoupling between the major components. So there's not too much interaction between more than two components, if that makes sense. Okay. So just to talk a little bit more about MVVM. So compared to MVP, and MVVM decouples the view from the view model by using the binder. So again, very important. Okay. Now, as I say, the binder is usually handled by can be a different platform or a third-party library, so that the developer doesn't have to write it. So that's going to be what we deal with within Android. The library itself has its own data binding mechanism. So what we need to do is bring in the dependency and then just go and use it. We don't have to write from the ground up the code to make that happen. Okay. The view model doesn't know about the view, or views subscribe for changes. So again, nice bit of decoupling there. So we can, the view model, when the view, if the view changes, doesn't affect the view model, doesn't affect the underlying data. Again, back in the MVC world, that would have been a big issue where, as I say, there could have been memory leaks, there could have been crashes, data getting lost. So all that is has been done away with. within this MVVM design pattern. Okay. Now the binder itself delivers the changes from the view model to the view. This allows developing and testing the view in isolation without breaking the view model. Again, because the components are all nice and separated, nice and decoupled, you can test independently, okay, which would have been a lot harder back in MVC, and even with MVP a little bit as well. Okay, now just on a kind of counter argument, MVVM isn't perfect either, but it is very good, especially in the Android development. And as I say, we will look at this pattern in more detail in later sections. Okay, so if we just compare all our graphics together, the different design patterns. So there's the original model view controller, again like that kind of triangle, but there's our model talking directly to the view, which is really not ideal as applications get more and more complex. Okay, our MVP tries to shift that. We bring in our presenter, our supervising controller, so we decouple the model with the view, but the view is still talking directly to that kind of controller. Okay, whereas MVVM brings in this binder, and all that is concerned about is handling events and updating, right? Technically not concerned directly with the data itself. That gets its updates from the view model, which in turn gets its information from the model. So as I say, there's a nice balance of decoupling there. Okay, it helps testing. Okay, so quick conclusion there. Design patterns are incredibly useful, no matter which language or platform you develop for. Every developer should know how to implement them, and most importantly, when to apply them. So there's, as you saw there in the different kind of creational structure of behavioral, there's a huge amount of design patterns that can be applied. So a big part of development and the kind of the skill level of the developer is knowing what pattern to apply at a particular when it's needed, when it's required, right? If you don't choose the right architecture for your project, you will have a hard time maintaining it as your code base grows and your team expands. At the moment, MVVM is currently industry standard recognized software architectural design pattern that overcomes the drawbacks of MVP and MVC. Okay, but it is generally applied to more complex type of applications. Okay, so just to wrap it up there, before rushing off and trying to implement these patterns on your app as soon as you can, right, it's worth noting that although these are good principles to abide by, using all or even some of them when they aren't really necessary can lead to overly convoluted code that ends up being harder to understand than it actually needs to be. So not every app needs to implement them, but the key is to know when it's time to start. So if you're building a quite straightforward, simple app, local data, maybe just listing some information, maybe even just read-only type data, that is it's just retrieving information and then just displaying it back for informational purposes. You don't need to go mad with all these really complex kind of design patterns. Okay, and there's dozens there that you could pick from. If it's a simple app, keep it simple. That's another kind of rule of thumb within the development world. You don't need to make it more complex than it needs to be. And as you will see when we work through the rest of the material and working into our donation application, it does become quite complex, but because we want to bring in more and more features. Okay, so as the features grow, it makes sense to apply a design pattern to allow us to scale up, and hopefully you will see that because we have used and are utilizing this MVVM design pattern, it will make adding new features a lot more straightforward and a lot less code necessary. Okay, so other than that, just some references for you there. So thanks for listening, and goodbye.